Okay, problem 3. The model below represents the equation x plus 7 equals 3x plus 3. Let's first make sure we agree with that equation that we've been given. We have 1x here and 7 chips, so that is x plus 7. And on the other side we have 3 x's. X plus x plus x is the same as 3x plus 3 additional chips, so that equation is correct. And we're trying to find the value of x. There's two ways to do this. I'm going to do it both ways. We can use the model, get rid of an x here. If I do that, I have to keep the equation balanced by getting rid of an x over here. Now I have two x's on the right side of my scale, and I want to have just x's. I want to get rid of these 3 chips. So I'm going to take these off the right side, and if I take 3 chips off the right side, I have to take 3 chips off the left side to keep the equation balanced. Now I know 2 x's equal 4, but I want to know what 1x equals, so I need 2 equal groups. I need 2 equal groups on the left side also, and you can see that each x corresponds to 2 chips equals 2, so x equals 2. You can do it with the equation also. Show 2 sides of the equation. I'm going to subtract x from both sides, which is the first thing we did when we used the model also. X minus x is 0, so I just have 7 is equal to 3x's minus 1x is 2x plus 3. I want to isolate the variable, so I need to get rid of this plus 3 with minus 3 on both sides. That's 0, and we get 2x is equal to 7 minus 3 is 4. I want to find out what 1x is equal to, so I undo that multiplication by 2 with division by 2, and 2 over 2 is 1, so 1x equals 4 divided by 2, which is 2. Same answer we got using the model. Now let's check our work. Original equation is x plus 7 equals 3x plus 3. If x is really 2, then I should be able to put 2 everywhere I see x. Instead of x plus 7, I want 2 plus 7 is equal to, instead of 3 times x, 3 times 2 plus 3. 2 plus 7 is 9. 9 is equal to 6 plus 3. Yes, it is. 9 equals 9. We've checked our answer. We can move on to number 4. The model below represents the equation 3x plus 2 equals 11. Looking at the key, the large rectangles are x's, so that this is 3x plus 2 positive ones, so plus 2 equals, we have 3, 6, 9, 11 on the other side, so that equation works. I'm going to get rid of these 2 chips over here and get rid of 2 over here, and then each x, if I make 3 equal groups, corresponds to 3. So using the equation also, 3x plus 2 equals 11, the first thing I would do is subtract 2 from both sides. Now we just have 3x equals 11 minus 2 is 9. And divide both sides by 3. We get 1x is equal to 9 divided by 3 is 3. Same answer. Now let's check our answer. 3 times, if x is really 3, 3 times 3 plus 2 should equal 11. 3 times 3 is 9, and 9 plus 2 does equal 11. So we've checked our answer. Another way to solve these kind of problems, if you're not sure, you could take each of these answer choices, plug them into the original equation, and see which one works. Problem 5. The model below represents the equation 2x plus 3 equals negative 5. 2x's plus 3 equals 5 negatives here. Looking at the key, that's right. So we can't subtract the 3 chips from this side because we don't have 3 to subtract from the other side, so we add 3 negatives to give me 3 0 pairs, so they go away. They each equal 0, and then I would have to add 3 over here. So I get 2x equals 8, and then if we make 2 equal groups, x equals 4. Let's do it with the equation a little easier. In this case, 2x plus 3 equals negative 5. First thing I want to do is subtract 3 from both sides. Negative 5 minus 3. Negative 5 minus 3 is negative 5 plus the opposite, which is negative 3. Negative 5 plus negative 3 is negative 8. So 2x equals negative 8. Divide both sides by 2, and you get x equals 8 divided by 2 is 4, and the signs are different, so the answer is negative. So x equals negative 4. Let's check it. 2x plus 3 equals negative 5. 2 times negative 4 plus 3 equals negative 5. 2 times negative 4 is negative 8. Plus 3 is equal to negative 5, so it checks out. Signs are different. We find the difference and keep the sign of the one with the greater absolute value.